So number 9 from paper 1 of the 2017 New Hire reconciliation question. 5 marks for this one in a couple of parts. 3 really. First bit. Here's a reconciliation with an unknown factor here. Given the first 2 terms in this, find the value of m. Well, what that says is, if you put in 28, you'll get out 13. So 13 will be the result of putting 28 in and multiplying it by m. So there's a little linear equation. You can solve that quite quickly. 28m, just writing the other way around, would be 13 take away 6, so that'll be 7. So m's going to be 7 over 28, which is a quarter. And part B, remember, you have to cancel things down in the higher. Don't leave that as 7 over 28. Explain why this sequence approaches a limit. Well, u approaches a limit. You have to write a lot of stuff down here. As n tends to infinity, because you're multiplying by a proper fraction, as 1/4 is between 1 and -1. And then there was that thing that appeared in the marking scheme of the last exam, whereby they might be expecting you to say, I don't know, and it is a linear, don't mean to put that down, recurrence relation. Important thing being linear here. It did say in that marking scheme that they were looking for that in future. And part 2 as it is, that was part 1. And again, still don't know whether they're really looking for that or not. Calculate this limit. Well, there's 2 ways. You can go in with the formula, or you can just say, if it approaches a limit, I'll call that L, I should have said there. Approaches a limit L. Well, if it reaches a limit L, that means that when you put L into it and multiply it by 1/4 and add 6, you should get L coming back out again. So you're stuck there. It's a fixed point. Well, take that across. You'll be left with 3/4 of L is 6. So L will be 4, take the dividing number across and multiply. 4 times 6, take the 3 across and divide. So that limit should be 8. Or you can just put your formula down. L equals B over 1 minus A. You'll get the same result. Now number 10 is a big one, 9 marks, area between 2 curves. There's a diagram with 2 intersecting curves, and it tells you the points at which they intersect, or the relevant part, the x-coordinates. And it says, what's the shaded area? What's this area here enclosed between the 2 curves on this side? And you just have to make sure which one's the upper equation and which one's the lower equation. So I put the lower one beside the lower. There's the upper one, higher up, luckily. Well, the area for that is going to be the integral from 0 to 2, because this starts at 0 and finishes when x is 2, of, and you just have to write it all down, the upper minus the lower. So the upper one is x cubed minus 4x squared plus 3x plus 1, and the lower one, keep it in a bracket because you're subtracting more than one term, more than one part, minus 3x plus 1, all of that dx, I imagine would be the first mark. Now, tidy it up. You could integrate that the way it is, it would still work. You're just putting in more arithmetic later on. So there's only one x cubed term. X squareds are going to go down to minus 5x squared. The 3x's, you've got plus 3 plus another 3 is going to be plus 6x, but at least the 1's disappear. 1 take away 1, so it goes down to that. Now you're ready to integrate. The power goes up by 1, divide by the new power, so that's a quarter. Or you can put it over 4. Next one, up to power 3, divide by 3. Next one, up to power 2, and when you divide by 2, that just goes down to a 3. Now it needs evaluating, so now you just have to write it all out, putting 2 into this first of all. A quarter of 2 to the 4. Minus 5 upon 3 of 2 to the 3, plus 3 times 2 to the 2, minus, now, well, they let you just put 0 in here. I'm just going to take it that they will, because that just disappears to 0. Now you just have to evaluate it, but it is paper 1, so I'll just have to show all the parts of this. Well, 2 to the 4 is 16, divided by 4 is 4, or you could just say there's only 2 powers left there, so that's 4. Nothing's going to cancel here, so that's just 2 to the 3 is 8, 5 8s are 40, so that's minus 40 upon 3. And in this one, 2 squared is 4 times 3 is 12, and it's minus 0. And it's all going to be thirds then. So what have I got over 3? Or maybe I'll show the working. So 4 would be 12, multiply by 3, minus 40, multiply that by 3, and that goes to 36. So altogether you've got 48 minus 40, which is 8 upon 3 squared units for the area. Now in part B, a line's been drawn, and it tells you the equation of this line, I'll just put it over here, is y equals 1 minus x. And it says, what fraction of the shaded area, the total shaded area, lies beneath the line? Well, that's equivalent to saying, now just do that again and find the area between this line and the lower curve. So it'll be the same as before, because they still intersect when x is 0 and x is 2. But this time the upper curve won't be this, it'll be just the equation of line 1 minus x. So I can just replace that part, but you can do that, you'd have to write it all again, with 1 minus x. And then you just start again. So it's 0 to 2 of, well, I've got 1, take away 1, so that disappears. I've got negative x, but plus 3x, so that's going to be a 2x, and I've got a minus x squared. Well, it's not as long then. dx. So that's just going to be up to 2, divide by 2 makes that a 1. Or maybe I'll show it, 2 over 2. Up to 3, divide by 3. Evaluated at 0 and 2. Now you just have to go through that. So that first one is just 1 times it. So that's just going to be 2 squared minus a third of 2 cubed. Take away, and that whole part just comes to 0. So that's 4 minus, and that's 2 to the power 3 is 8, 8 upon 3 minus 0. Now 4 would be 12 parts of 3, so 12 take away 8 means this time you've got 4 upon 3 square units. This is for the lower area. So when it says what fraction of the area have you got, well, the fraction will be, well, that was 4/3 out of the 8/3. Multiplying both parts by 3 gives you 4 over 8, which is, it's exactly half. Well, you could have just stated that, because 4 bits is half of 8 of the same bits. There we go.